Okay, we're gonna do a real quick review on some area formulas, things you probably already know, but just may need a quick review somewhere. So our first one is gonna be the area of a rectangle. And the area of a rectangle is length times width or base times height. Fun fact, it does not matter what part you call the length or the width or the base or the height. We can call this length and width, or you can call this width and length. Doesn't make any difference. Same thing with base and height. We can call it base times height, or we can call it height times base. It doesn't make any difference. The one thing that we do want to make sure with height is that we do make a right angle. Anytime we talk about the height of something, it should make a right angle. We also could talk about the area of a square. Area of a square is the same, length times width, but because the length and width are equal, we usually call them sides. So side times side or side squared. We'll also do some things with compound area where we'll have some shapes maybe like this, and you'll have to separate it off yourself. So you'll be given some information like 10, 7, 6, and maybe 4, like that. And you'll have to find the area of this figure. So you'll want to separate it off. And, oh, I put that in the wrong place. Doop. This guy goes down here. 6. So we could say this is 24. And we could say that this is 70. And so the area of that figure would be 70 plus 24, which is 94. Now, a lot of teachers will make you do units squared, so make sure you ask your teacher. I am not one of those teachers. That's just too much extra work. Remember, mathematicians are lazy. We like the easy route. So I just leave it as 94. Now, if it did give me units, then I would want units in the end. So there's your area review for rectangles and squares. Parallelograms are similar, but we're going to do those on the next slide. Okay, so now we're going to talk area of a triangle. Area of a triangle is 1/2 base times height. Now this time the height does actually matter. So when I take my triangle, my height is the altitude. So I have to make a right angle. That's got to be my height. My base is what I make the right angle with. So we could draw that anywhere we wanted. So I could go this way and make a right angle this way and turn that into my height and this into my base. But still, it has to be the two lines that are perpendicular. Those are what make up the height and the base. So be careful when you're doing problems that you make sure you pull the right height and the right base. You do want to recall what we did before with our 30, 60, 90 triangles. So when we had a 30, 60, 90 triangle, if we knew that this was 30 degrees, the side across from 30 was our x, the side across from 90, or the hypotenuse, was our 2x, and the side across from 60 degrees was x radical 3. So you may need to use that information in order to find some of the different areas on the homework. Also, don't forget about our 45, 45, 90 triangles. Those are our equilateral right triangles, like this. Or equilateral, I apologize, isosceles right triangles. So both of these would be 45, 45. So we would say this is x, and this is x, and this is x radical 2. Again, you're going to need that to solve some of the problems on your homework. Last in this section was the area of a parallelogram. And a parallelogram is the same as a rectangle. It's just base times height, but in this case our base and our height, again our height has to make that right angle, so it's not just the length of the side like it is in the rectangle. We have to look for this right angle here. That's our height, and again the side that it's perpendicular to is going to be the base. So there's your triangles and parallelograms. All right, now we're talking about the area of a trapezoid. So remember, what is a trapezoid? Well, a trapezoid is a quadrilateral, meaning that it has 4 sides, but the 2 bases are parallel. It doesn't matter anything about the sides. If the two sides are congruent, then we're calling it an isosceles trapezoid, but those don't happen a whole lot. So we're going to focus on this. We can call either one of these base 1 or base 2. Those are interchangeable. And then our height, again, same as before. Remember, there's a lot of patterns in mathematics. So our height here is going to make the right angle. So the area of a trapezoid is given by the formula 1/2 base 1 plus base 2 times the height. Now, there is one other little piece in a trapezoid that you may not have heard of before, and this is called the median in a trapezoid. So again, we go here. The median is the midpoints on the sides, and they don't have to be an isosceles trapezoid in order to have a median. This is my median. It connects the midpoints on the sides, and the median is actually the first part of that area formula right there. It's this guy right here. Okay, that's the same thing. So it's 1/2 base 1 plus base 2. So if you're given the median and say the height, then you can find the area of the trapezoid pretty easily. And I believe there's one of those on the homework for you to try. Okay, so now we're going to talk about area of a kite. Now remember, a kite is, again, a special quadrilateral, and it's a special quadrilateral where the two disjointed sides are congruent, so like this. And we do make a right angle, and this diagonal right here, I'll do it in blue, this guy right here is bisected, meaning that these two pieces are congruent. Okay, so our area formula is diagonal 1, and diagonal 1 is our blue guy. This is diagonal 1. And then I'll change it to red. This is diagonal 2. Well, and it doesn't matter. You can call them 1 or 2, 2 or 1. But the area formula of a kite is 1/2 diagonal 1 times diagonal 2. And that's all there is to it. Now, do notice that we have this lovely little section right here that makes a really, really nice right triangle. Boop. Now, don't forget, we also have some nice Pythagorean triples. And if we use our Pythagorean triples, we can do less work. Remember, we're all about trying to do less work. So 3, 4, 5 is a Pythagorean triple. If I have 3 and 4 in a right triangle as the legs, then I know the hypotenuse is 5. Any multiple of 3, 4, 5, so 6, 8, 10, etc., etc. 5, 12, and 13 is another pretty popular Pythagorean triple, and any multiple of 5, 12, and 13. And then another super popular one is 8, 15, and 17. I would say that these guys are the three most popular. 3, 4, 5, 5, 12, 13, and 8, 15, 17. If you can recognize that, you will probably save about 10 to 30 seconds off of a test. And an ACT would be a great place to save that extra time. So there you go. There's your review of your areas: kites, trapezoids, parallelograms, triangles, and squares and rectangles.